So our view of the world is that automation will change drastically. It will go away from this originally very hardware-centric ladder logic, one step after the other, process-driven, to a compute software-defined automation. So we go from hardware-defined to software-defined automation. So we want to get our customers work at the speed of software and be data-driven. And that is, if you like, the real revolution that will happen, because that might change everything. When we talk about Industry 4.0, the real goal, the simple goal that we have is we want to make all of our customers be much faster, because now we can use all these digital realm to do whatever you want to do 100 times, a million times even faster, because it just depends on the amount of data and compute you have. And then when you do it in real world, do it first time right.
Welcome to the new automation mindset, where AI, automation, and integration come together. I'm your host, Markus Zirn, and as Chief Strategy Officer and part of the founding executive team at Workato, it is my mission to find these top innovators in AI, automation, and integration and share their journeys with all of you. So today, I'm really excited to have with me Dirk Didascalou, and Dirk is the CTO of Siemens Digital Industries. Siemens, obviously a huge company, been around for 175 years. So it's done
176.
All right. Sorry about that. Got that wrong. Point being, you guys done this for a long time, so you better. I think there's something must be right.
Well before my time.
The part that Dirk has is basically digital industries, which is basically all factory automation. Maybe in addition to the 176 years that Siemens has been in business, this year 2024, Siemens was the keynote at CES. So there's a lot going on. It's not just like being around for a long time, but a lot of innovation, a lot of digital innovation going on. So from that perspective, like really, really excited to have you on, Dirk. So what I wanted to start off with was, you guys talk about automation. Workato talks about automation. Same word, but I think we're talking about different kind of topics. So maybe you can help us a little bit when Siemens, when digital industries talk about automation. Tell us about your world of automation, factory automation. What is this all about?
Yeah, first of all, thanks for having me on your podcast, Markus. It's really appreciated. And you're right. I mean, for us, we assume everybody understands what we mean by automation. But if we had to define it, we would define it as the use of control systems, computers, program logic controllers, and robots and information technology to handle a lot of industrial processes and machinery, replacing human effort, particularly in the case of producing any goods. And whether these are concrete goods like a car, a mobile phone, or rubber boots, or whether these are more on the process side, whether this is chemicals or paper that is continuously produced, it doesn't matter. It's these control systems that we also produce ourselves as products that then automate the factories and the buildings of this world. That's what we understand when we talk about automation typically.
Yeah, it's really interesting. So Dirk and I, we both studied electrical engineering. The funny thing here is my specialty was actually factory automation. And now it's reverse worlds. Like years later, we come together and Dirk is the expert. No, but this is really cool. I think, look, in IT, Workato is all about IT, of course. Automation kind of started in the factory. I mean, it started with the robots. It started with the controllers. I think that's in IT almost like took this on a little bit and said like, okay, what can we do with automation? I'm actually curious, like, obviously Siemens, I heard you guys have like these best practices of what like a great automated factory could look like. I heard about your own factory, I think Amberg, where you make electronics. Tell us a little bit, like if someone gets automation right in your world, what does that look like?
So there are different levels of automation. And I think that's the first thing to understand. In the very beginning, it was just to make sure that the machine can move as it's supposed to do. That was, if you like, basic control. And that was the first level of automation, going away from a human being is doing something, but a machine can do that. And what has developed more or less in the last part of last millennium was what we call the totally integrated automation. That was the idea that Siemens really brought to the field, where you said, you know what? All of the different machines actually can work in concertation. And that means automation needs to be seen between the different machines, not just an individual machine. And we put a lot of systems out. That is the so-called total integrated automation pyramid, where we say, hey, we have the field sensors and motors and machines, and on top you have the control layers, and on top of that you have then the MES, the manufacturing execution system, and on top you would then have the different type of ERP systems, and on top of that you might even have everything that is related to customer relationship management and your real sales processes. And if you like, that's the pyramid, and we are typically in the first three levels where we're really strong. And everything what we were doing over the past decades with so literally tens and tens of years, was optimizing these automations. So make sure that the factory robots, conveyor belts, numerical machines, which are bending metal or doing anything else, are doing what they're supposed to do. And that was, if you like, the state of the art since a few years ago, before quite a lot of new modern technologies came to place. One of that was what I was my specialty. You said you were automation engineer and electrical engineering. I was on the telecom side, where you're saying, hey, you know what? Now you can actually connect stuff. You can connect a machine, you can connect a phone, you connect an asset, and also what the cloud offers us, so that there's a lot of new software and compute technology at mega scale and sensing at mini scale. And that allows us now to go beyond just the automation domain, where you can say, what if automation is not just a specific cell in a factory, but what I automate everything that I do across my value chain. And value chain is then not only I produce something in a factory, so I have raw material come in and I have maybe as I said, a rubber boot or a car or anything else coming out. But it's, okay, what happens before? Because you have to design that product. And where do you get your supply chain from? So where are your pieces coming from? And because Siemens is not only world leading in automation, we are also world leading in what is called engineering. So it means the tools that mechanical, electrical, chemical, or any type of engineers use to design their products. So we're saying is, why can't we combine this knowledge, means where you conceive a product already digitally with CAD tools, simulation tools, PLM tools, you name it, and then have that automatically transferred digitally into the factory so that you can optimize your entire manufacturing process from the get-go, because you know what you want to produce and you have experience. And if you think this further into, I could do this in the field and I can understand how I recycled later on, then you get this new idea, which at least in Europe, people typically talk about Industry 4.0, where you combine the IT, information technology world, with the OT, the operation technology world. And then, of course, if you combine IT and OT, you get IoT. Don't confuse this with the Internet of Things, which is a different thing. It's really, when we talk about this Industry 4.0, IoT, we mean the merge of IT, information technology, with operation technology, and what you could do applying modern technology also in the factory and industry environment.
Yeah, it's really interesting. So, we use the word automation for Workato. Sometimes we regret this a little bit, and we started actually using a new word just for that reason, which is orchestration. All right. So some people prefer orchestration. I think it shows that connectivity a little bit. One of the things we struggle with, we wrote this book, The New Automation Mindset. And it's kind of, we put new in front of automation because a lot of people, and I think you faced the same situation at Siemens, I believe. You tell me if I'm wrong, but when you think of automation, even if you go to the dictionary and you look up automation, it's defined in the sense of a robot in a factory. It's basically doing what it's supposed to be doing. It doesn't do anything new. It doesn't typically use any data around it. It's not like smart and adaptive. It follows a clear repetitive pattern. And so we're always told, hey, if you use the word automation, that means that okay, Workato would only be for like, well, automating, quote unquote, like is something that's manual, make it automated with technology. But people say like, okay, that it doesn't mean that you're actually innovating, you're improving, you're making that process better. And we disagree, of course. That's why we picked the word orchestration. But tell me a little bit about this. I think when I listen to Siemens and what you're trying, it's like you challenge your customers to become more data driven, right? So you talked a little bit about the engineering. Tell me what you think. If we say like Workato's the new automation in IT, what's the new automation in the factory? How does data driven get into that?
I think you hit the nail on the head, because automation typically means you follow predefined steps and you try to always have the exact same steps over and over and over again to ensure quality. So that's why everything is process controlled. So you said you have a process that you have to follow. Even the way how you program these programmer logic controllers is stepwise. Step 1, step 2, step 3, all in a given time frame, all guaranteed. It's called a ladder logic. It's actually not programming. That was when electrical engineers had to figure out how to program and there were no computers. So you needed to have almost semi-mechanical, electromechanical systems to execute certain steps. That's where it all came from. And that means you don't care about your environment. You just follow process steps. Now comes digitalization. And now you said, you know what? Maybe you don't have to stupidly follow process steps. Maybe if you have an awareness about your context, you might be 17 times in a similar situation, but if each time you have a different context, you might take different decisions. Means you use data, what is happening at this point in time, to make different decisions. And that allows a very different type of optimization in factories. Because what I'm always saying is, when you're on the motorway, and it's what you try to understand is, how do I optimize the overall flow? And if you have somebody who's driving as fast as it can, typically you slow down the entire motorway, because then some other people have to break down and brake, and then you have these queuing effects. And the same happens in a factory. If you optimize individual machines to be as fast as possible, then we have terms like OE, operational effectiveness, and so on, you might clock your system. So it's not about the individual parts, but the overall system. And it might be counterproductive, saying, you know what, you need to slow down that machine so that the overall output is faster. And that you can only do if you understand the full system. And that means now data plays a role, context awareness played a role. And instead of following a process, I need to understand my value flow and be data driven. And that is a significant change in how you do automation, because that means also the ladder logic, as you have to do this step after the next one, might not be the right thing to do. You have to have then intelligent decisions. And if you now make this even further and spin this further and say, of course, with new data technologies where you can do instantaneous decision based on machine learning means stochastical models that people now call AI or whatever else, then you can do stuff that you could not even do before, even as a human being. And that, of course, makes this entire thing so much interesting. So our view of the world is that automation will change drastically. It will go away from this originally very hardware-centric ladder logic, one step after the other, process-driven, to a compute software-defined automation. So we go from hardware-defined to software-defined automation. And since I worked before Siemens at AWS, which of course is somehow the one who drove what a lot of people call today infrastructure as code, we try to do the same with industry. And our vision is, what if we can define industry by code? So if it's all software, because software, of course, is much faster. So we want to get our customers work at the speed of software and be data-driven. And that is, if you like, the real revolution that will happen, because that might change everything.
It's fascinating. I mean, you guys go from the hardwired robot in a way to a much more sensory aware, data aware kind of software environment that's wrapped around that robot. And then we'll have to hold the horses. We'll get to the end. But with this Gen AI world, you might actually then, in addition to adding the sensory awareness, maybe will actually add a brain even to it, and then it gets really wild. But But so the one thing that before we get there, what I wanted to talk about, you mentioned already, you were at AWS before. You ran IoT, the other IoT. That's the
Internet of Things. Exactly.
The Internet of Things stuff at AWS. But there's more. All right. So, again, started off with electrical engineering, but then you went on to actually build phones, right? Like, Siemens, BenQ, Nokia, long time at Nokia, all over the world, like, China and Denmark and wherever. So you have an appreciation of consumer hardware. Obviously, you were at AWS then. You have an appreciation of infrastructure, cloud, really, and now you're doing the Siemens kind of industrial hardware, B2B hardware kind of thing. So you, in a way, you've kind of done it all. I'm curious what you learned from these experiences. It seems like you've been through like lots of transformations in your career. The phone, you've seen the iPhone happen, you've seen the mobile revolution, the iPhone happen. You lived that cloud transformation in B2B with AWS. I guess, now you're living the transformation in the factory. What have you learned from all of this, or what are you taking? What are you drawing from these experiences? Just curious.
On first sight, you could say it's all random, yeah? And of course, I can always post-rationalize things, but there's of course some consistency in this. So as you said, my first revolution was the mobile revolution, and which gave us the system and chips so that everybody can sense. And what I learned in consumer electronics, particularly in phones, was scale of hardware. And I mean scale, mega scale. Nokia was counting phones by the 100 millions and by the billions. So my teams and myself, we did products which were the single individual phone years ago were selling at least 100 million a piece. And when you took it all together, we were talking about billions before anybody was even knowing about these numbers. So you learn about economies of scale in hardware and what that requires. And that changes quite a bit of stuff that is counterproductive, because when the advent of the smartphone came, I was originally in the feature phone business, so the phones that you put next to your ears. Of course, every little piece of BOM counted. You say, okay, I need less memory, and we had a lot of SKUs, means stock keeping units, means you have a ton of different phones. And then you try to do that. But then came the smartphone, which more or less commoditized the hardware and saying, because today, an iPhone, regardless which one you buy, or an Android phone, in essence, is the same in life, apart from the screen and the camera. And that means you get now in different scale categories. And what was then funny was that when we were trying to get, we need to squeeze our software for a feature phone in 32 megabyte, the 512 megabyte chips were much cheaper, which should physically make no sense, but because of the process nodes and its scale, you were just getting them for way cheaper than the now much cheaper smaller ones. And then you realize, wow, you need to really understand economies of scales in hardware. That's what I learned in my Nokia times. And of course, what I also learned is you can get disruptive even if you're king of the hill. And I was at Nokia when it was the most valuable European company in 2007. I think 240 billion euros at that point in time, which happened to be the year of the introduction of the iPhone. And 7 years later, I was sold to Microsoft for a mere, what was it, $8 billion. So from 240 billion euros to $8 billion in 7 years, that can show you if you miss a disruption, what does it to you. So my learning was a lot about how you do scale at hardware, but be careful how you can disrupt and how fast it can be. That was my major learning over there. And I was then lucky because Microsoft shipped me from China to Redmond, where the headquarters were, where I started working for the first time with the cloud. And then I decided to go across the pond on the other side in Seattle, work with the AWS. And that was then really, okay, the second revolution, the internet revolution. So if you have all of these connected things that can produce a ton of data, where do you store it? Where do you compute it? And you need the biggest storage and compute, and that's, of course, the cloud. And I went into this and then dived into that, and it was a very different world because distributed compute and the service you do that's where you learn about software scale and how different software scale is compared to embedded software, and that you need to think very differently, because in the embedded world, you try to build a hardware and software that never fails because, MTBF, mean time between failures, low. In distributed world and cloud, you assume that things fail and you try to build as resilient system as possible, saying is, it will fail, but I build a system that I can immediately detect and remediate it, because it's impossible to build these systems that they never fail. And every now and then, you still see the glimpse when AWS had potentially a big outage, or just last weekend what we saw with CrowdStrike, nothing to do with the cloud, but again, stuff just fails when you have that mega scaled software. And that's what I learned there, the scaling of software and the other disruptive power of not the mobile revolution, but the internet revolution. I was on the being disrupted on the first disrupting in Nokia, and then being disrupted from, if you like, Apple and everything that happens with the iPhone and the app economy, and then with AWS on the internet revolution, and then the cloud on disrupting anybody else and seeing what that can do to companies with the thousands of customers we had. And my logical step for me was, now you know these two things, where does it really have a lot of impact? And you can, of course, use those technologies now to do, consumer products or cat videos, or you can go, which is me important, which really matters to the environment. And industry and infrastructure is, of course, a really big part of human life, because that feeds us and houses us and moves us. But at the same time, it also had, of course, a really negative impact on the environment, because we produce a lot, but we consume all of the resources and energy and CO2. And therefore, we're saying is, if these new technologies can have an impact on industry and in infrastructure, it most likely has an outsized impact on what we do on the planet. And of course, we're better to go to one of the world leaders in industry, and that was Siemens. And for me, that made sense. And why I was hired, I guess, was because I have that understanding about scale and being disrupted in hardware. I know a little bit about software, working now a few years with AWS, because this disruption, using those technologies and going through a disruption in what does it mean for a hardware-centric, very traditional company in infrastructure, which means building infrastructure, not IT infrastructure, and automation. And that is, again, what happens in factories. And in doing the software transformation is what is my daily business nowadays.
Mm. It's interesting. I'm not sure if you know, but Vijay, our CEO, co-founder of the company, the big inspiration for starting Workato was that, so Vijay was in the integration space. He was a founding team of a company called TIPCO that does very B2B enterprise software, used on Wall Street, used by FedEx, that kind of stuff. I met him at Oracle. We worked there together. But then what he did, he did a consumer software company. He did a company called Quick. You might actually know it. It basically got sold to Skype. It was like video streaming on phones, like before FaceTime was around. And the lessons that he had were similar to you. What you learned with consumer electronics was like, man, this is consumer software. Actually, reliability was actually a much bigger issue than at TIPCO, even though that powered the FedEx and the stock markets. I mean, it was supposed to be down at certain points. People expected it. Your consumer service, it just could never be down. It was, the people would shout and go on the barricades. I mean, you had a completely different level of availability, and then also a completely different level of scale. As you said, right?
Yeah. The thing is, if your stuff don't work and people send it back, that's the worst thing that happens, because all of your revenue or your income is down the drain. Somebody sending back your phone you need to repair is a disaster. Because if you sell a phone that maybe makes, at that point, it's years ago, I can tell you the numbers now. If you sold a phone that was worth $15, which you make on a profit, but an average return sale of a phone is at least 50. So, you can imagine what happens if some of these phones are broken. So you wanted to be them as reliable as possible, because otherwise you would destroy it. And if you go at mega scale at hundreds and millions and billions, this is a lot of money. So again, what consumer shows you gives you a lot of respect for scale and what scale does really do, both in hardware and software, which is difficult to understand if you didn't live it. Because if you think, and in my company now, we think that $1.5 million of a product of hardware is a lot, which of course in my early days at Nokia, we wouldn't even touch and think about it. But of course, if you take all of the SKUs, means the different hardware devices that Siemens does, we are also doing hundreds of millions. So the overall scale is there. They're just so different. And they're saying, what if the world is different? We're saying, what if we standardize on hardware? Which, by the way, would make it also easier and cheaper for our customers. And you don't have the supply crisis because you can do much more in standardized hardware and everything becomes software. So you become so much faster. And again, the goal, why we do this overall transformation, when we talk about IT and OT conversion and we talk about Industry 4.0, the real goal, the simple goal that we have is we want to make all of our customers be much faster and move at the speed of software instead of obey to all of the physical laws you have, because now we can use all these digital realm to do whatever you want to do 100 times, 1,000,000 times even faster, because it just depends on the amount of data and compute you have. And then when you do it in real world, do it first time right. That's the promise. Much less resources, much faster. And that means speed of software. And that's why we always talk about digital transformation. But in essence, it is do whatever you can in software. And that's when we talk about this digital twin, for example. So we use all the fancy words, but what it means is a digital twin is nothing else, a digital representation of a process or an asset. And saying, if I have a high fidelity representation of a process and an asset in the digital world, I can do a lot of stuff much faster than real time. And that, of course, you still have to pay for compute. But at scale, that also goes down, still much cheaper and much less resource consuming if you do it in the real world. And that's why digitalization and moving at speed of software is so fundamentally different for industry, again, and infrastructure. And again, when I talk about infrastructure, I mean building infrastructure or physical infrastructure.
So we saw the same in our world, integration software. We felt, and that was Vijay's take also, what we did was too complicated. It didn't have the speed. It didn't have, you needed too many people. It was too manual. It was too, I think, overcomplicated. And so the consumer experience was that kind of thing what if we just simplified a lot of these things, go about this with a consumer mindset, actually build it, Workato runs on AWS, runs on Kubernetes containers, runs in a cloud architecture, the whole infrastructure piece and scaling piece was actually transparently almost like we take care of that. The customer doesn't need to worry about it. It'll just work. Here's the issue. And I don't know how you see that at Siemens, but what we were running into, the customers, the enterprise customers, they didn't appreciate all that stuff. They would go and they look at this and so oh, that's kind of very simple. So I'm probably sure you can only do simple stuff with this. Well, that was the first assumption, right? And then the other thing is so how do you run it? You run it on the cloud. It's oh, cloud. No. That's not, cloud is not enterprise. Great. It's this needs to run on premise. Do you run into these kind of situations?
Oh man, we run into this every day. I still even run this into my own company. When I was at AWS, that was the most important thing. What we always had to teach people saying is, so you think the cloud is less secure than the little device that is sitting under your desk in your garage? Are you sure? Because we can show you how easy you can crack that. And again, this myth of, again, it's typically for people who have a very physical notion that said, if I can touch a computer and it's in my garage, I feel it's secure. Because the digital realm I can't grasp. That's also why it's called the cloud nowadays. Yeah, because it's how do I fathom? I can't sense bits and bytes. But the notion, when you know what it really is, it's highly secured data centers where professionals do nothing else to make sure that you secure it, which you would never do if you're middle-sized, an SMB or SME. That means, okay, the ideas of the cloud is not secure or is not available. Now you have seen that actually the most sensitive applications and the most sensitive both to protecting data and operations are actually running on the cloud today, because what's the most sensitive thing that you can do? It's typically defense of a country or everything related to your financial data, because you want nobody to mess with your money. If you know that all of the financial institutions now and all high frequency trading is all done on the cloud, and if you know that also all of the the government services realize that the best way for them doing this is on the cloud, they use specific clouds so they are not accessible by everyone in the public, but the technology they still use because it's at the end cheaper, better, and even safer for them. And of course, now that people realize this, it's an educational thing. My old boss said always, Andy Jassy was saying is, you can't fight gravity, because once you realize how much faster, easier, and better that is, one day you will realize and just go there, regardless of the FUD that people tell you. And then it's like a switch. And I remember when I was at AWS, and at that point in time, all the European companies, including the one I'm currently working for, Siemens, which is my home, they were saying, oh, we will never go to the cloud. And not Siemens. Siemens was already on the cloud trip. They were working with us very much. But their customers were saying, no, never, ever. We would never go to the cloud. It's insecure. And then we did a little deal with a company called Volkswagen, which happened to be the biggest car manufacturer in the world. And they went out and said, our digital production platform, DPP, what they call then their industrial cloud, they will build with the key partner AWS. And that was made public. And you know what happened the next day? The phones were ringing from morning till night, because every single company in Europe and Germany who said, I will never work with the cloud, called us, said, how can I go on the cloud? Because if VW does it, apparently that's something we need to understand, because there was just fear on not understanding. And when you have these moments where people say, hey, the ones which everybody follows is doing it, we better look at that. And that just shows, again, as we said, you can't fight gravity. That changed quite a bit also in industry. And kudos to Siemens, because Siemens realized this almost 2 decades ago when they started buying a lot of software asset all in the PLM space and started investing in a lot what we do on the cloud, making a lot of mistakes. Don't get me wrong. We learned a lot on our hard lesson at Siemens, but there's also no compression algorithm for experience. So you need to have this experience to understand, how can I use these technologies in these very operational environments, because you have to ensure that the factory runs. You need to make sure that there's safety, because these machines can kill people. It's not just you're in a game and you start reset. I mean, if a robot arm hits you, it's dangerous. So you need to have safety knowledge. You need to guarantee stuff. But all of this you can in reality also solve today in software. It's just that people are not used to that. And therefore, we have the same situation like you had, that there's a lot of customers still which are skeptical about the cloud, which don't really understand the technology because they have never worked with it and they don't have the experts. And I see it as our obligation, yours in the IT domain, with Ricardo and us, with Siemens, that we are able to explain this to our customers and show them what it really means and show them the benefits, because then they will understand, and seeing is believing. Don't listen to talk, just see what you can actually get out of it. And I guess once customers of yours were seeing, oh, you can do a lot with Ricardo for really enterprise application, they changed their mind, I guess.
No, it's true. It's true. And I mean, I also have to admit, like, we were happy, when the CrowdStrike thing happened, it affected these desktop PCs, right? That were all over the place. We are running on AWS. Nothing happened. We were fine. Like no issues. While our customers were struggling with their whatever they had on-prem or in their PC kind of applications. So I think that's where you see again, people, you said it yourself, the security, there's sometimes a false sense of security. What is secure? And if you realize, once you see a little bit below the surface of how is that built, it almost like you're starting to understand, like your on-premise IT feels almost like your generator in the garden. You can touch it and you can see it, but it's actually not that reliable. And the cloud infrastructure is like a nuclear power station, really, that's there. It can scale up and down. It's huge. It's managed by professionals, and it's very unlikely something bad happens there. But it's a change management process. I think it definitely, we've seen it over the 10 years at Workato. We've seen it evolve in the right direction quite a bit. So that's good. Listen, so there's the cloud. And that has simplified things and made things more scalable, really, more consumerish. And then there's the low code part. Again, we always believe like that, there was too much programming, too much technical knowledge. There was this bottleneck in our world of integration automation where you needed someone who was dedicated 100% of their daily work had to be just doing integration. Otherwise, you couldn't do it. Now comes low code. And you guys at Siemens, you acquired Mendix. You're in that low code business as well. Workato is low code integration. Really, tell us what low code means to Siemens. Why this is important for you. Why you're betting on something like Mendix also.
Yeah, look, our customers are engineers, but typically not software engineers. As I said, there are product engineers or process engineers, so mechanical, electrical, automation, you name it. And they typically don't know how to code. They were never educated in coding. They are specialists in their field. And they're all very clever people, and they need to somehow handle logic. And everything that now we talked about, the cloud and the services, of course, typically tools for software engineers. And particularly when we go even in more sophisticated data handling, then you also go into data science. That means none of them have that expertise. The same also goes for small and medium-sized enterprises, where you have actually millions in the world. They all produce sometimes smaller and bigger. And of course, they can't even afford having a lot of specialists in their workforce because they're just small businesses. So how do you make sure that they can benefit from all of these technologies? And there, low-code plays a massive important role, saying is because this allows you to do something much more naturally that you're used because you're used to interacting with a screen, be it an iPhone or an iPad or anything else. You can see boxes, you can do stuff graphically, and you do programming without knowing that you do programming, and all of the complicated stuff of understanding that in reality you do some API calls in the background and there is some ETL with data happening is all done by Mendix or by Workato for what you do in the ERP systems. And we bought it because we realized that is really important also in automation, because as we said, we believe in this convergence. And our own people in the factory, if they saw something, even people with no education, if you like, or very little working in the factory, they're all clever because they do their job. If they wanted to do something, they had to call their boss. They had to figure out, they have an idea, maybe we can put this into a project, and they had to get somewhere funding and they had to ask IT to build this for them, and it never happened. And now we have what is called Mendix installed, and our factory workers, they can literally build their own applications because they know what's happening on the shop floor. They know what data sources are available and said, hey, it would be super great if I had this little app which can tell me if I, with the barcode reader, figure out something is wrong. I put at that point in time on a button, and then in the system it tells my colleague, oh, you have to have a second look on this. In the past, it was all paper. And we have these literally hundreds of these applications that then are popping up, all of them really meaningful because they're digitized stuff now, but they were never written by a software professional. Were just done by the experts who knows their field but can't do programming. And that was the reason why we bought Mendix, because we saw this tremendous improvement in productivity for people who simply don't know programming languages, but at the end need some logic to do their jobs automated better, whether it's now the automation we talk at Siemens, or I guess it's the same for you, the automation on business processes. And what we really try together now is how can we even combine those? And I mean, I really believe this is a very powerful tool for efficiency.
Yeah. No, we saw exactly the same thing. I mean, for you, it's the factory workers, it's the people who know these control systems. For us, it's the people who know the business applications, SAP or, Salesforce or whatever. Like, why couldn't that person who knows these business systems, why can't they just also wire them together? Right? To me, it feels like, if you want the benefits of being software defined, of making this easier to kind of, as you said, look across the entire process, not just the islands of it, you have to make the software more approachable. You have to bring it to people who are not software developers. I think that's what it all boils down to. Okay. Well, this fascinating. I mean, all right. So I said before we got to get to Gen AI somehow, and we're almost running out of time here. There's a lot of more things I could ask you, but I want to get your take on Gen AI. So I have a feeling, in automation, I feel like we stole from you guys. I think a lot of the ideas of what we're doing actually started in factory automation, to be very honest, right? You guys started this concept of the digital twin. It's something that you use all the time in factories and so on. So we did it again. We stole again. And so what Workato is actually announcing at the conference. So think about, there was the concept of a digital twin of an employee. All right. So this is a person. So let me explain this a little bit, and I'm then just curious what you guys are doing with Gen AI. But what we're thinking, and this is again in terms of making that adoption of these automation technologies easier. Because one of the things that we realize is today, so we made it easier with low code. You don't have to program anymore. You have now a visual process. That's fine. Reality is people with that process mindset, maybe in the factory it's a little better, but in IT, we actually see a lot of people who just really struggle with a process understanding of things. They have a really hard time. You can ask them what they do. They can tell you what they do, but then to come up and draw a flow diagram, they really struggle. There seems to be that mental hurdle. So we said, like, now we got Gen AI. All right. So how about we build again this digital twin of an employee? One of the processes we do a lot is order to cash process. From ordering. You guys can relate to that. Something you produced, you order it, it gets to the supply chain, and it gets into the general ledger in your finance system. That's a typical end-to-end process. Before you had to define all the boxes and the steps and the flow and everything. How about I just define a digital twin of my order management clerk and my supply chain clerk and my finance clerk, and they have an LLM, they have a brain, they have functions. It's kind of like their arms and the legs of what they can do. Some of this is going to the ERP systems or supply chain or warehousing systems and so on. But then, and you feed them with some knowledge. All right, so there's a RAG architecture where you put like knowledge in and so on. But now they actually you dispatch an event, order gets created, and now it goes through a network of these digital twins of employees. They talk to each other, they do their things like how you defined them, and the process almost like magically appears. You don't actually have to define it, they figure it out. So it's wild. I just wanted to mention, because I think it's kind of the digital twin is now appearing in software, which I think is kind of cool. But what are you guys doing at Siemens? You have an environment which is probably more challenging, as you said, because what you do, you want to be very safe and deterministic. As you said, robots can kill people, but what's your thinking about how's Gen AI, how's Gen AI going to impact the factory of the future?
But first of all, I was saying it sounds really intriguing what you explained there about you now have your agents as individuals based on LLMs and then figure stuff out.
It's called Workato agentic. Is the term.
From agent, I guess that's where it comes from.
Yeah. That's exactly right. Yep.
It's awesome. I love this because you see all of the creativity now. What could you really do with this? But one step back, what you call a process or what you write down, we use sometimes fancy language, so excuse me for that. We call this a digital thread because for our customers, there are these digital threads saying, okay, what do you need to do from design to production, for example? Or what do you need to do if you want to do a recycling? Or what you want to do for anything else? So you can think about, How do I produce actually more sustainable with CO2 neutrality and things like that? That means you have to think through the entire value chain. We call this a digital thread, and we typically prepare them based on the years of experience we have in the different industries. So what you're saying, if I get you correctly, is you can figure those threads out automatically within a company based on the data and the interaction that the systems have, which I think is super interesting to follow up. For us, it's based on industry knowledge that we get over years. But now talking a little bit about what can we do actually with data is what I maybe didn't explain beforehand. Siemens is also the leader in simulation, because we built all of these engineering tools. We are one of the leaders in CAD, so CAD and CAM systems, or PLM, Teamcenter, for example, is, if you like, the tool that you use for product lifecycle management, the big database where all the BOMs, the bill of materials, bill of process are created. But we also do a lot of what we call SimCenter, so simulation centers where you can do very sophisticated mechanical, electrical, or computational fluid dynamics simulation based on numerical models. And of course, that means we have means to really try to model real physical processes and digital as close to reality as possible. The problem with these is they typically sometimes tend to take quite some time in compute. So if you think about a car that you optimize, and then you figure out what's the resistance, the air resistance, what you do, and they typically take some hours. And then you change a parameter, you try to redefine this as well. And what we started doing was we used the knowledge of the physicality, the physical knowledge of the process that we have, and figured out how can you do physics-based AI. So that you don't have just a dumb neural network that's a black box, you train this from data, but what are the boundaries of the physical process? Or if I do a lot of simulation results, can I go to surrogate models that in reality are statistical models that mimic the outcome, like a CFD, computational fluid dynamics, like star CCM plus from Siemens, and then you can get an almost real time everything that you do. So our research, we also have a research department, it's called Siemens Technology. And the biggest part is what we call our data analytics and AI team. And for years, they look at three major things. They look at, okay, how can I work and do AI that has boundaries in the physical world? So this is physics-based AI. And that helps us a lot with the situation that data that we need is not typically publicly available for training these large modules, because in the internet you get text and video, but who gives you process data of their factories, or who gives you data of how they produced or designed their phones or time series? This is typically modalities that are not available. And of course, so figuring out how can we get to this information using physics-based model is really big center of our research. And the other thing is it helps you to make AI explainable. You all know about large language models, and they hallucinate. If you know what the boundaries are, you can actually explain why some of those physics-based models then produce a result that they do. And that is a big part of research, because the two problems we typically have is the modalities that we are building in are not trained and not available. So we need to figure out how we get to this data. And the other part then is, okay, we don't have enough customers who then apply. I mean, there are billions of people who look at cat pictures. But if you figure out, is there somebody who has maybe a stamping process for metal parts? Maybe there are 1,000 customers in the world. So that means even though the use cases are very valuable, so you don't have as many customers. You need to have a very different economic equation. And what we are trying to figure out is how do we make the application as easy as possible, again, without that you be a specialist and train your own model. So what can we do? And how can we use physics-based AI and sparse and understanding about sparse or federated learning, overcome this so that we can actually train AI that is relevant for automation. And now I came to, so I hope that makes any sense. So because it's not the standard AI you do, it's very specialized AI. And what we realized, of course, is we could use large language models, and we do as they are today because it's easy for interaction with text and the modalities. But we do quite some very specific modalities that nobody else in the world does. One is artifacts in product design, like CAD models, 3D CAD models. Nobody trained in large language models and CD 3D models. Or, of course, we do a lot and have a lot of knowledge. How do you program PLCs, ladder logic? So what are the parameters of maybe P&D designs for real big process factories? Or what are the best ways to program robots or machines that is yet another modality. So they are and time series, of course, the behavior of machines. So what we are looking into, how can we extend this general purpose LLMs with complete new modalities which are applicable to specific industries? And that is, of course, what nobody else can do if you don't have access to this data, or if you don't have the means to simulate this data, and you don't have this domain expertise. And that is, of course, where you can dream very big. Think about, in one point in time, you said you have your machines figuring out the process by itself. What if you could say, you know what? This is a type of product I will create. Tell me in which factory and in which configuration I could produce this the most efficient, means the cheapest and fastest. And by the way, program it for me. Or you could say, how could I produce this in the most sustainable way with zero CO2 and most recyclable? Because what engineers do in automation, they get typically a product design and they need to figure out what machinery and setup they need to create and how do they program that, which is a very complex piece of pattern matching. But what can LLMs do the best? Yeah, pattern matching, once they are trained on all of this different data as input. And that's, of course, now is the idea that we are driving with our customers, saying is, what can you really do in the industrial domain if you use these new technologies? And then, of course, you can blow your mind and say, wow, maybe in the future, automation will be very different. Maybe I don't need engineering anymore because automation engineering can be done automatically under certain circumstances. We are not there yet, but that's something that we do with companies and partners like, for example, Microsoft, which is a big partner. I talked about AWS, which is a big partner of us for our SaaS offering, but Microsoft also and a big partner of ours when we do everything in AI. So we just start smelling the possibilities, and I think we are really early, but on the good in this domain. But on the other hand, we also have a few years of experience in what I call industrial AI.
Yeah, 176 to be precise.
Not AI. I don't think we do.
Not AI, but in kind of doing the stuff. So the domain knowledge that you can train.
But having specialists only looking at, as we said, statistics, machine learning, data analytics in that domain, we literally do for a few decades because we have this, what we call technology fields in Siemens. And there was quite some foresight of our predecessors who said, hey, maybe we should invest in this.
That's cool. Listen, really, really appreciate the time that you spent here with us. And I hope the audience also appreciates the time. I mean, realize that a lot of the audience here is IT folks. So this maybe was like a new world for many of you guys. But I do think that looking in the related areas is actually really, really cool and gives us new ideas about AI, gives us new ideas of really even like thinking about exactly what is automation and what do other people do about automation. And so, yeah, I hope this was valuable to all of you guys. But Dirk, thank you so much. And yeah, very, very, very exciting to see what's going to happen to the world of automations in factories and in IT for that matter.
Thanks for having me. And I had the exact same shock. I had no idea about the complication in automation and infrastructure and engineering. It's a fantastic world. And what I love, I come back to the physicality. This is what happens in the real world. And now we can use all the technologies of IT, of machine learning, of the mobile and the internet revolution and the AI revolution for a bigger purpose. So, if you're interested, come give me a call, join us. There's a lot of work to do.
No, it's true. And I hope also you guys saw a little bit like this whole fear of the cloud and maybe that sense of like, oh, low code is only for simple stuff. I mean, it's something that's happening in many, many domains. And I do believe we all come to the same conclusion. This is like, if we really want that fast adoption, if we want to help all of you guys to become faster and more agile and so on, there's really no other way. I think
more sustainable, exactly. So the two things, move at the speed of software and don't fight gravity. That's for me the two sentences I always have in my mind. Move at the speed of software, don't fight gravity. And that's what we try to do here and with impact. So thanks again for having me, Markus.
Awesome. Thank you, Dirk. Thank you so much for tuning into today's episode. Please make sure to rate today's episode, leave us a comment with your thoughts, and subscribe to the show so you will never miss an episode. I'll see you next time.